Lossy compression. We're going to examine the benefits of lossy compression on text and images. Given a piece of media, we're going to decide whether to use lossy or lossless compression based on the needs of a situation. So, first, our warm-up. This widget claims that you can keep the first letter of a word, then remove all the vowels, and the result will still be readable. We're going to test it out, and we're going to see some other sentences that we could try with it. So, this is not something you need to do. This is something I'm going to do. I hope. We'll see. Okay, so here's this glossy text compression widget. The first text that's typed in up top says, I have a theory that if you keep the first letter of every word and then remove all the vowels, that the text is still readable by a person. Is that true? Okay, down here, I have a theory that if Y, I'm not sure I would know, probably would get the U, keep the first letter of every word and then remove all the vowels, that the text is still readable by a person. Is that true? True. Yeah. Okay. Based on this to here, it's compressed 22%. I think that's true. So far, it looks good. What are some others that we could try? Well, I can make my own. Oops. Go back. There we go. And what if I do cat jumped on the roof? The CT jumped, I can probably get jumped on the R. Roof, rail, rug, rim, root. It's hard to tell. Okay. What are some others? You could type in school starts too early for many students. Boom. School starts early. Maybe, maybe not, because you know what it says. It might be easier to do. Okay? Come up with some more sentences, and I will be happy to try these. Okay? But now, what if I did something nonsensical? Like, the cat ran up the mountain with a flower. Okay, so I'm just doing something nonsensical. The CT ran up the, it might be a little harder to figure out what that was. Okay, so if we come back, boom, is it? This widget is similar to yesterday's widget, okay, because it shortens the text. And this is something you should know, which means it's compressing the text. It is different in that some of the information is permanently lost when it is shortened. I could potentially pull out the wrong thing. Instead of jumping on the roof, the cat could have jumped on the rug or the rail or the rim or one of a dozen other words that might start with an R. Okay, if we wanted to try, there are 3 tiers of tires at the shop. Okay, well, let's try. There are 3 tiers of tires at the shop. That doesn't make any sense. It would be really difficult to recreate that. You've lost information, and highly unlikely that you would always get back what you started with. There's no way to reverse it because obviously we have THR and THR. This is there, this is 3. That would make it very, very difficult to figure out what you were talking about. Okay? If we're losing data, is it really compression? Actually, it is. You are compressing. You're losing data. But what we try to do is we try to pick things where we can lose some data and not lose the meaning. When does that happen? Well, we're going to find out today. The widget used in our last lesson was an example of lossless compression because we could always reverse the process and recreate the original. The widget just now used is an example of lossy compression because some information gets lost, making this process not reversible. In some cases, it's easy to figure out what the message was, but in other cases, it just wasn't. For this particular lesson, we're going to investigate how lossy compression works with images, because we can use lossy with images and with sound, because we can lose a little bit of the clarity of an image and a little bit of the sound, and people can still know exactly what we meant. So, to do this lesson, you will need to head out to Code Studio Lesson 10, Level 2. Okay? Code Studio Lesson 10, Level 2. And you should see Lossy Compression Widget V1 Level 2. So everybody should be there. Open a separate window. Okay? Now you're going to adjust the slider to see different lossy compressions. Here's your slider, so you can move it left and right. Look at the sample size, look at the original size, and then the compressed size. Okay? What do you notice about the quality of the image when you compress it? What do you know about the compressed file size? Now, when you do this, it's going to come up and it's going to say something about run. You must click run in order to start playing with it. So, play with this widget for a few minutes. We may not take the whole 5 minutes, but play with it for a few minutes and make a note. Write down your answer to these two, and then we'll come back together. Since you're doing this as a video, just pause, take up to 5 minutes, don't take more than 5 minutes, and then come back. Great. Now when I look over here and you look at that, can you tell exactly what it is? I think it's a school bus. It could also be a smiley face. I'm saying school bus just because the green looks like maybe ground and the blue looks like sky, and it kind of looks like a school bus. But it's a little bit hard to tell. We're going to go ahead and, well, before we go on, if we're in class, I'm going to ask, what did you notice about the quality of the image? Obviously, it deteriorates. It gets worse. The file size of the compressed file gets really small. Here we have this school bus that went from 201,600 bytes down to 3,321 bytes. And it is somewhat recognizable as a school bus. Maybe not 100%, but it's pretty recognizable. No detail, however. So the greater your compression, the less recognizable, the more that is lost. The less, okay, the greater the sample size, the less the compression, the greater the sample size, the more you can tell what it is, the greater detail exists, but then the file size gets bigger. So we're going to have some trade-offs. Lossy Compression Widget version 2. In this one, you're going to go to the other browser you have open. You're going to pick a new image, anything off the internet. Just pick an image, clip it out, put it in, or pick a picture off your computer, whatever you want, and then find a compression that you still think represents the original image while maintaining a high compression rate, low number of bytes. Be ready to share your compressed image. And by the way, if you have, and please don't disturb them if they're truly working like at work or at school, but if you have a parent who's taking a break or a sibling who's taking a break from their schoolwork. After you find your image and you compress it, try compressing it down and asking them if they can recognize what the image is. In other words, if I look at this here, I recognize this as a giraffe. It's got a sample size of 7. It went from 201,600 bytes down to 4,278 bytes. That's pretty good. If I compress it much more, I might not be able to tell that it's still a giraffe. All right, for this one, giving you about 10 minutes because you actually are picking out an image and then compressing it and playing around to see which one is the best. Okay? Great. You're back. Okay, share out. Now, for this, it's a little bit hard. You want to try to guess the image. So if you are simply watching this video, find somebody else in your house, a friend, whatever, share out the compression and see if they can tell what it is. At what point did they first, and you can even compress it, make it so it's totally unrecognizable, and keep bumping it back to find out at what point are they guessing the image correctly. In class, we'll try sharing around screens and see what people have and see where they feel like they've got the compression down. Okay? Now, you've seen that lossy compression can greatly reduce the file size of our images, but we lose some information, in some cases a lot of information along the way, and we lose a lot of clarity and detail. We're going to explore what this looks like with some common image compressions we use on the internet all the time. So, in this one, you're just going to walk along with me, and we're going to look at how much. We are trying to use this image for a particular purpose, and we need to decide how much lossy compression we want to use. So here's a picture taken off a CCTV of a city street. In our first scenario, you are sending this as a text message to a friend, but you've almost run out of data on your phone plan. So, are you going to send it with no compression, small amount, a medium amount, or a large amount of text compression? Which one are you going to send? And at this point in the chat, you can either put in 1, 2, 3, 4, or just think about which one would you pick and why. Okay, there's no right answer. Part of it would depend on what I want my friend to see. If I'm just sort of sending, hey, I'm here, I might do a medium. If I want them to pick out some little bit of detail, I might send a small amount. This would probably be rough, okay? Maybe I would send this, but that looks kind of like a Lego city, but it's up to you. You are a crime scene photographer, and this image is part of a crime scene photo. What would you do? 1, 2, 3, or 4? In this case, I would pick no compression. If I'm a crime scene photographer and it's a crime scene photo, I want to be able to zoom in on the details. And as you zoom in, you're going to see that detail is lost. But I want as much information as I can possibly have before I start zooming in and checking things out. Not to mention, I might want to be able to identify some of these people back here. As soon as I start compressing, I can barely tell how many people are there. This image is part of a satellite imaging assignment for the military being used for intelligence gathering. Which one would you use? Again, it all depends. If I'm trying to pick out if I think there is, let's say, a terrorist, and I want to alert the local authorities so they can stop them, I might want no compression because I really want to get into the detail and make sure that I've picked out a particular person. On the other hand, if I'm just looking to see if there are civilians in the area, I might go with 3 or 4 because I'm just looking to see, are there people in the area? Are there buildings in the area? What kind of an area is it? Is it populated, not populated? So 3 or 4 might be good. Scenario 4. You are a social media manager posting to an Instagram story for an event happening right now. You might do 3 or 2. You probably don't need it super clear. Again, 4, I don't know when I would ever actually use 4, other than maybe to see if there were actually just people in the area. But 2 or 3 is probably where I would want to go. And part of that is I want it to look good. I want to entice people to come to the event. If it looks too grainy, people might not come at all. This image will be part of a collage where 100 copies will be stitched together to make a larger image. Okay? Maybe 3, 4, but I'm talking about a huge 100. Nobody's going to be looking at anything in much detail. So maybe 3 or 4, and especially if I'm going to make it smaller. Scenario 6. You are a professional photographer submitting to a design competition where your submission will be carefully judged for color and composition. What would you pick? If I'm being judged, I'm going to pick number 1. I definitely want them to see all the color contrasts that I have, all the detail minutia in the picture. If it won't send, I might send 2, but I really think 1 for this particular scenario. But again, there's no right or wrong answer to any of these. Okay, you could pick 1, 2, 3, or 4. Maybe 4 you're going to send because it's more abstract. It's more impressionist and not based in realism. Kind of your choice. Now, as a wrap-up, when is it a good idea to use lossless compression? When should you use lossy compression? Remember that you're responsible for those vocabulary words and you have to know the difference. What are the important factors in making that decision? Stop the video and jot down your responses to those 3 questions. And remember, I'm not collecting these responses. This is for you in your notebook. So when we go back and you review for the test, when you review for the exam at the end of the year, you have an idea of what you're looking for. Okay, 2 key takeaways. Lossless compression. It's useful when the accuracy of the original item is the most important thing. Example, bank records, text files, and some images. Lossless, like the crime scene photo. Okay? Lossless. Lossy compression. This is useful when file size is a concern or when it needs to be sent in a reasonable amount of time. Think about multimedia, especially streaming media, images, video, and audio. Now, while we don't compress it down quite as small, there is some data lost when you send files or images or videos over the internet. Okay? Think about when you embed a video in a text message. It actually compresses it for you. And when you watch the video, you can see the cat or the dog or the person doing whatever it is they were doing in the video, but it's not crisp, it's not clear, it certainly is not 4K. Okay? But that's because you want to send a quick thing to get the idea across to somebody of what was happening. So lossy is when file size is a concern or the amount of time to send it is a concern because you want to make it smaller. Great. Lossy compression, your vocabulary term for this lesson, a process for reducing the number of bits needed to represent something in which some information is lost or thrown away. This process is not reversible. Can't reverse it. So once you go from all of these up here down to here, you can't go back with 100% certainty. Next, in AP Computer Science Principles, we are going to look at intellectual property. This will be the final lesson with information for this unit.